Hello there, Internet world. This is the SMC Journal podcast, the show that is all about software engineering, systems engineering, performance, testing, tuning, security, AI, observability, and the list goes on and on. If it's something hot in IT, we are probably talking about it on this show, and I am Scott Moore, your host, and I really appreciate you being with me. How about mocking? Mocking is not just something that I do to developers or for JMeter. Actually, there's something called service mocking or service virtualization out there, and it doesn't get talked about enough in IT. So I wanted to bring that to your attention on today's show, and I've got a guest who has a very long history of doing that that's also in the performance engineering space. But before we get into that, let's talk about the sponsors that make this show happen. This episode is sponsored by OpenText, the information company. We power and protect information. Our purpose is to elevate every person and every organization to gain the information advantage. OpenText works to power the ubiquitous information around us to elevate everyone. We strive to help customers simplify their systems with frictionless automation and equip them to thrive and grow in a digital world. The LoadRunner family is one of many solutions where OpenText can help. Did you know that LoadRunner has the largest community of load testing professionals in the world? Check out the QR code or go to their website at opentext.com to find out more about the LoadRunner family. Some of you may be aware from previous shows, we've had SpeedScale on the show to talk about their particular product in doing performance and load testing in pre-production environments. However, did you know that their CEO, Ken Ahrens, has a history of working on service virtualization products, and they actually have one built into their product as well. So I wanted to bring Ken on to speak specifically to the service virtualization conversation and sometimes called mocking, service mocking, and what all goes into that, and how do you actually get it into a CI pipeline, and what are the fundamentals that people need to know about it. I thought it was a great conversation, and so I'm going to bring him on to the show. Let's talk to Ken now. Hey Ken, welcome to the SMC Journal podcast today. It's always great to have you on the show.
Awesome. Thanks, Scott. Glad to be here.
I know we've had Nate on the show in the past with, I know you're with SpeedScale, but some of our audience may not have been introduced to you. So why don't you just tell them who you are and a little bit about what you do?
Sure. Yeah. Thanks, Scott. So I'm one of the co-founders of SpeedScale, and my background is really in the performance engineering space. Almost all of my career has either been on the production side. We've got performance problems in production. Let's monitor the systems and try to find and fix things fast. Or on the pre-production side, where it's always about how do we run more tests? How do we find these things and prevent issues from reaching production? And SpeedScale is on the pre-production side. We're about trying to figure out how to prevent problems from happening, as opposed to how to fight fires as fast as possible.
You know, in this space that we're in, testing isn't going anywhere. And one of the common problems that I'm always running up against is environments. We don't have a production ready environment. Maybe we're testing when everything is not completely baked in yet to the product. Everything is sort of decentralized now anyway, as we're piecing apps together. We have upstream and downstream dependencies. All of that stays with us today, and it's getting more complicated. And there is a topic that I really want to discuss. It's not discussed enough in IT, which is virtualization, service virtualization, mocking. They've called different things. I know that you have a background in that, so I really wanted to focus on that, not just for performance engineering, but for testing or any use for it. And so why don't you tell me a little bit about your history with service virtualization and mocking and why it's so important?
Yeah, I mean, I totally agree, by the way. People think, hey, I got to test my app. First thing I should do is write a test case. No, the first thing you should do is a site survey. Okay.
Right.
What am I trying to test? And I like to start with drawing a diagram. I have a web app, and then what does it do? Well, it gets a message and it writes a database or reads from a database. And is that it? Oh, well, sometimes it calls a third party like Stripe or who knows, right? We're going to charge someone on their credit card. We got to call Stripe. When you start to do that site survey, you run into this environment challenge. And you say, where am I going to run these tests? Well, we have an environment that we're going to run them in. And then how frequently are we going to run the tests? As frequently as we possibly can. And all of a sudden you start to realize this environment becomes a critical part of it. The tools of service virtualization or service mocking is about getting control over that. That's it. Okay. If you can use VMware or virtual machine or a Docker container and make an extra copy of your app. You can make an extra copy of your database. You cannot make an extra copy of Salesforce. If you make an API call to Salesforce, you need their sandbox. You need another endpoint. You need one with test data and that kind of thing. Same for all these kinds of third-party APIs. And that's where I've spent quite a bit of time early on in my career, like you mentioned. Kind of a long time ago, I worked on the service virtualization space. We focused at that time on legacy platforms and systems. You can't get enough mainframes and AS400s and things like that. And what's happened in the cloud native world is this has shifted to things like third-party APIs and the services you use from your own cloud provider. Even modern things like we use ChatGPT. When we get an API call, we send it to ChatGPT's API and get a response. That's part of your environment. Mm-hmm. Service mocks are a way to bring this in your control. And I think people think they're hard to work with. They take a lot of coding and development and that kind of thing. And the tooling's getting a lot better. Sorry, I can go on and on about it, but service mocking at a high level is about taking these things and bringing them in your control. Now that you're under your control, you can do all your tests.
And based upon what I'm hearing, this is going to become more and more important because we're doing, cloud native development. There's more dependencies than ever. So it's definitely going to be something I think everybody's going to have to do and be thinking about. Now, here's a question that always comes up when I start talking about this virtualization. Okay, so when we make a call, let's call this a dummy call. Let's say we were to make a call and we get back an error. Errors come back really, really fast. When computers have to do work, they come back really, really slow. So if I'm making this dummy call to a fake system, that's going to, the performance engineer in me says, oh, that's going to be really fast responses, so it's not going to mimic real world behavior when I'm doing a performance test. But that's not necessarily the case, right? There are mechanisms built into mocking that allows you to simulate long tasks and work done by servers. Can you go into that a little bit?
Yeah. This is totally right, Scott. So a couple of things. For one, Hello World is great to learn how the system works, but no apps actually use a Hello World API. They use a real API. Like I want to go to Salesforce and download a list of contacts that match Scott Moore, right? And I'm put in a query and I get an array of data back in the, so the data needs to be correct. And then the second part is what you're talking about is the performance of that endpoint. Sure, everything runs super fast and it's all cached at the edge and so on, but there's milliseconds involved. And by the way, your point about errors returning real fast, when I worked at New Relic, we did scientific analysis of the data, and errors have the highest performance. You can get the most throughput on your app by immediately responding with error codes. But the real app might take 50 milliseconds to respond. You might have an SLA with your vendor that is in a particular category. And when you design your application component, you want to make sure if you're simulating something outside of your control that it has the data characteristics, which includes the data volume and size, maybe they're really big messages, and the performance characteristics. So it should be the same number of milliseconds that you see from your monitoring tool. Yeah.
What would be really important to me is if I'm running a load test and I want to see, okay, if this third party tells us that there may be times where they're going to have high usage and it may go from 100 milliseconds to 200 milliseconds. Well, how does that affect my shopping cart behavior? Or what does that do to all the other calls that are dependent on that if it starts getting backed up? Just being able to have some kind of a slider in there that takes it from an extra 100 milliseconds. What does that do to the system as a whole? That's really important to be able to do. And I know that modern virtualization platforms do allow that. So that's something I don't think a lot of just load testers, performance engineers just think about when they start thinking about load test. Oh, we need to build that kind of mechanism in there, but it's there. So give me an example of how things have sort of changed from when you were first working on virtualization for legacy systems to how it's used and how easy is it to implement in more modern systems that you're building.
Yeah, sure. So yeah, it used to be a pretty big, basically a software development effort, right? Where you've got to understand what are the systems you're working with. You got to realize in the legacy kind of tech stack, there was a lot of proprietary technologies involved. So I'm not trying to point fingers at any particular vendor, but there's this is primarily vendor driven, right? We're using an Oracle stack, an IBM stack, a Microsoft stack, and they each have proprietary systems for how you communicate with them, whether they are real time or queue based interactions. Those are the two most common, synchronous or asynchronous kind of calls. Nowadays, a lot of things are standardized on HTTP. And HTTP 2.0 actually solved a lot of the problems where you would need different kinds. You'll notice if you go into a cloud service like Amazon and one of their popular database products, for example, like DynamoDB, you talk to it over HTTP. Or S3. Everyone knows S3 is used for storage. Believe it or not, all the calls are over HTTP. And Google Cloud, when they have been coming up, and they're really focused on things like the machine learning APIs, right? So let's say I have a speech to text API that you might call. Those are gRPC, a lot of them, and that's over HTTP too. So one of the good things is these standards actually are kind of working, and people have standardized on common ways to communicate. And that's not for everything. There's still databases. You talk to Postgres, it has its own, way that you talk to a Postgres API, and it's not over HTTP. But a lot of the new kind of cloud native approach is primarily HTTP based, and you'll see things like OpenTelemetry work real well with them as well because they're based on some common standards that you can reason about. So service mocking nowadays is if I can get a stream of this HTTP traffic and I can get a big volume of the traffic, you can actually build a model out of how the application behaves. That includes the data, how you call the API, what endpoints you call, and the response time characteristics and things like that. So the time to value for a solution like SpeedScale, we're in the minutes and hours kind of time to value area where you can get a recording and build data pretty quickly. Whereas in the past it tended to be days and weeks and collecting a lot of info from people and a lot of custom development and that kind of thing. And so we're more in the kind of capture traffic point and click arena nowadays.
That's impressive. So then the next step would be companies getting into continuous performance. How do you get service mocking into the CI pipeline and as early as possible? Is it the same, or is there something special you have to do?
So I mean, the good news is it's the same. Okay, at least for the modern solutions like SpeedScale or some of these other open source projects are all available as Docker containers, and the modern CI pipelines are very container friendly. Okay, so it looks like GitHub Actions and GitLab CI/CD, and a lot of people are using these, and Docker is a first-class citizen. So running a Docker container is trivial. We'll also have some customers who have Kubernetes clusters that are dedicated to CI/CD pipelines, and you can then do a workflow through GitOps and say, when I've built the next version 1.10, it will automatically get deployed in the environment. And when that happens, I'll automatically run the test and provide the feedback back. Well, guess what? You need service mocks because as soon as you're running these on a regular basis, you're going to run into environment problems. So you use a service mock to knock out each one of those environment problems, and you can hem your environment in. So I actually, this may be a little, I don't think you can be successful with continuous performance testing in your pipeline without service mocking.
Yeah, especially because when you're doing that, everything is not going to be built out, and you're not going to want to call real backend systems across the cloud for sure. Let's talk just a minute about metrics, though. So if you've got a mocking mechanism, what type of output should you expect from it? Is there a way to actually monitor the virtualization calls and get number of times and any statistics that it can report back into some type of visualization to show how well you're actually doing this mocking?
For sure. So you want to include as much data as possible. So in the non-prod world, I always sort of try to balance towards more data versus having the most tuned environment. You can tune it when it gets in production, but in non-prod, you might need a little bit more data. And so, of course, you want to get your SRE golden signals. You want to understand the latency and the throughput of your application, the saturation, how much CPU and memory and the error rates that are coming out from your testing tool. And the same goes for your service mocks. Okay. And actually service mock has the same. Well, for one thing, we know the latency and can report on it, right? We've been sending back these responses like your example, the 200 millisecond ones. And errors are actually cases where the service mock didn't know what to do. Right. So a common example is I got a call that was unrecognizable from the traffic that was provided. And you have a choice of what to do with that. But like one choice is you can return an error. Another choice is you can pass it through to the real backend. But either one is not a match. And so you report on that metric. The match, no match, pass through rate is analogous for the error rate, at least when it comes to the service mock. I don't know if that makes sense. And then these metrics, typically you want to expose them through Prometheus, or you can just push them at the end of your run, push them to your your observability tool of choice.
Let's talk about some of the actual offerings for service virtualization. I know that some load testing tools will actually have a service virtualization component that they include with the product. Some of them are separate licenses, separate purchases, and I know there are open source. I know SpeedScale, you were talking about SpeedScale, you have a service virtualization or mocking mechanism as well. Can you talk to that? And maybe if somebody's interested, hey, I want to dive in a little deeper and find out what's out there, what would you advise them?
Yeah, for our view of the world, we want to have a complete suite because, like I said just a minute ago, if your goal is to really do continuous load and performance testing, you need an entire suite of capabilities. And so we include everything. We have a service mocking module. It's available as a container called a responder and can be run automatically, like I said, in a Kubernetes cluster or Docker container. You can run it on your own machine locally. You can run it on a VM. So anywhere you want to run that. Test driver. So a lot of people have their favorite test driver, and I always want to use this one or that, or maybe their least favorite. That may be another way of how people stack rank.
Right.
I don't want to get you going, but. So we provide one of those as well. And then our mechanism of the data that powers it is the actual API traffic itself. So it's a traffic-based solution instead of a script-based one. For our product, we offer it. You can come. It's a cloud service. You can go and sign up on our website and take a look at it. But there's actually lots of open source tools. I know a real popular one for a long time is WireMock, and people are familiar with that. And there are a lot of tools when you talk about mocking, people are familiar with from unit testing. And I do want to point out that unit testing tools like Mockito or Spy, and I'll never end the names of all the tools, but those run inside your code and it is different. And those they tend to be a little higher on the labor because you have to write all of the code for them, and so they're used more minimally. Like I've just got to put it around just this database call. And I will point out there's another set of capabilities called test containers, where if your application just needs a particular kind of container, like I just need a Postgres hooked to my app, I just need a MySQL, a Redis, a Kafka, something like that. Test containers is a good pattern to use, so that it'll spin up a container and connect it to your app as part of the unit testing primarily.
Wow, that's a lot of good information. And we'll make sure if you can even after the show provide me with a couple of links, I'll make sure I put them in the show notes where people can check out this. And if they want to check out SpeedScale and the suite of stuff that you offer, where do they go to find that out?
You go to speedscale.com, or you do a Google search for traffic replay, traffic replication, Kubernetes load testing. You can find us, I think, pretty easily.
Awesome. Awesome. Well, I can't believe this time went by this fast on the show today, but we'll have to have you back and we'll talk about more of what's going on, because I know you're always making improvements with SpeedScale, and you're doing more as things are changing out there in our world in the landscape of application development. But love to have you back on as soon as we can. Thanks for being on the show today, Ken.
Okay, that's great. I really appreciate it. Good to see you. Thanks a lot, Scott.
All right. So how do you feel about this conversation? Do you feel mocked? Maybe you do. Or if not, that's great. Just let me know what you think. You can reach me on most social media platforms. Scan that QR code or go to the My Links bio page, and it'll tell you how to get in touch with me through many social media platforms. I'm always available. I'd like to know what you think about this. Should we be talking about service virtualization a lot more than we do? You can send me an email at heyscott@smcjournal.com. Are enough people talking about this? Do you like this kind of video coming out? If you do, it would be great if you subscribe to our YouTube channel. I really appreciate everybody who has done that so far. It's been great to see all of the additional subscriptions, and I'm looking forward to more. So thanks for watching today's show. Until I see you on the next episode, this is Scott Moore saying bye-bye, and we'll see you next time.